Network management. In this nugget, we're going to talk about various network management tasks. First, we'll talk about NIS, the Name Information System. NIS gives you a way to share certain information across all the computers in your network. We'll walk through the setup of an NIS server and an NIS client. Then we'll talk about setting up a DHCP server on your system, and we'll wrap up by talking about PAM, which is the mechanism used to authenticate users by many different network applications. So pull up a chair and let's get to work. Let's start out this nugget by talking about NIS, the Network Information Service. This was a program written by Sun Microsystems, and it was written to enable Unix machines and Linux machines to share information over the network. Now, in the old days, this was called Yellow Pages service, but the name Yellow Pages was actually a copyrighted name, so they changed the name over to NIS. You'll see some remnants of the fact that it was called Yellow Pages in some of the names of the configuration files and the software packages that we're going to install. The very first thing you have to do to get a network information service running in your network is you have to set up what's called an NIS domain name. For our network here, I've called it nugget-NIS. All right, this needs to be a name separate from your host names and things like that. Then, once you've got the domain set up, then you need to add things to that domain, and the first thing you should add is a master server. This master server on our network is going to be the Nugget SUSE machine, and this is going to keep track of shared information on your network, things like the password file. All right, so you don't have to have, so if you have a whole network of computers, you don't have to have like a password file on each one, and then when someone changes their password on one machine, it doesn't change on the other machine, and that causes headaches, right? So having this centralized information on the master server makes management of the network easier, and it also makes using the network easier, because then users can sit down at any machine in the network and log on, and they're going to have, one sort of unified password for the network. Okay, so that's our master server. It's set up that holds the shared information. Then there are clients in the network, and on our network, it's Nugget SUSE 2 is my sole client. So when Nugget SUSE 2 boots up and it gives you the login screen, you type in your username and your password, that's going to be verified over here on the master server. And then if that authenticates it, then it's going to say, okay, you can log this guy in. All right? And that's the kind of thing that NIS does, is enables you to have a centralized data source. Now, one thing we haven't talked about with regards to NIS is the idea of slave servers. We don't have any slave servers in this network because we have such a small network. All right, but if you had lots and lots of clients, then you don't want all these requests going to the master server and bogging that down. That would be a bottleneck in your network. So instead, what you do is you set up slave servers, any number of slave servers, but you always only have one master server. And then anytime anything is changed on the master server, like someone changes their password or something like that, then the master server contacts all the slave servers and gives them that updated information so that then they're up to date. So in case some client is requesting information from them, they'll be getting the most up-to-date information from the slave server. All right, so that's an overview of how NIS works. The kind of software that you need to have installed on your system, the first piece of software you need is the port map program. This is usually installed by default and started up by default as well in most Linux systems, but if you don't have that, you need to make sure that's installed, and also that it starts when the system boots up. And then ypserve is the software package for the server machine, and ypbind is the software package for the client machines. And you can see the YP stands there for Yellow Pages, but that's copyrighted, so it stands for something else now. Okay, so that's the necessary software that you need to have installed on your system. So now let's move out to the Linux screen and look at some of the configuration tools and see NIS in action. Okay, so let's bring up the YAST interface, and we're bringing this up on the Nugget SUSE machine, which is the machine that we've designated to be the master NIS server for our network. All right, so if I click on NIS server here, it'll bring up this other YAST page, which is the NIS server config page. And here you see it says an NIS master server is configured. That's because I've already done everything, but if this was the first time that you came into YAST, this would say it's not configured, and down here instead of saying reconfigure the master server, it would just say configure the master server. So here I'm going to click next, and now this is where we set up the domain name. So in here is where we specify that the domain name for our NIS system would be nugget-NIS, and that's the name for the server, or the domain, and that's what we have to specify here. Okay. The other thing I've checked here is allow changes to passwords. You can also allow other sorts of changes to happen, allow users to change their login shell and so on. In the next page here is where you set up the information that is going to be shared. And it's shared via these files called maps. So that's why it's called NIS Server Maps Setup. And the files that we're sharing, the group file, NetID, password, and so services, RPC, and so on. And you can see some of the other things that you can share as well, like hosts and so on. Okay, so that's another file. Then the next thing you do is you set up which hosts can query the server. All right, so here what I've done is this line must be in here, 255.0.0.127.0.0.0. That must exist to allow connections from the local host. So when the host is making these changes, you need to have, the host itself really is a client as well, right? So so that makes it so that the host can configure, can access the server on the local machine. And then this is the line for the other machines in my network. So I've got a 192.168.1 network, and so I give it a net mask of 255.255.255.0, and that will resolve to anything that starts with 192.168.1. All right. So then I click Finish here, and it goes through, and it updates a variable, various configuration files. It updates the database. It stops the NIS service, and then it starts it back up. And now the NIS service is up and running. All right. Now what I want to do is move over to the Nugget-SUSE 2 machine and show you what I had to do there to set up the client side of things, and then we'll also do some commands from there to test to make sure that things are working. Okay, now we're out on the Nugget-SUSE 2 machine, and on this machine I'm going to bring up the YAST interface and click NIS Client, and if I do that I'll get this NIS Client configuration page. Now on this page I've said use NIS, and I've also given the NIS domain, which is nugget-NIS, which is the same for every machine in the domain, and I've also given the address, the IP address of the NIS server. Now you can see up here I've clicked Static Setup. A few nuggets ago we were talking about the configuration of my local home network, all right? And at that time what I did was I had the router configured so that it would assign IP addresses automatically when the machines would start up. The router got a dynamic IP address from my ISP, but I also had it configured so the router assigned dynamic IP addresses to the other machines in the network. Well, since then I've switched it to static because I thought it would be easier to do a couple demonstrations. It turns out it's no big deal to have it set up to be DHCP. I could click here, automatic setup via DHCP, and then instead of giving an address of the NIS server, I would just click broadcast here, and what would happen is as long as the NIS server machine was started before the NIS client machine, the NIS client would then broadcast over the network and basically find the NIS server machine to hook up to. Okay, so so you don't need to have it be a static machine. I just thought it would be easier to explain. So here you can click Finish, and then what will happen is the client program will shut down and the client program will start back up, and then you'll be hooked up to your NIS server. So once you have your client up and running, you can test out to see if it's working by using a ypcat command. You can cat out the password file, and putting, the ypcat command goes over and uses NIS to determine what password file it is that it should be printing out to the screen. All right. You can do the same thing with the group file. That's another shared file, and so you can use ypcat to print that out to the screen. So that tells us that we have a connection here. Another thing that you have to do is just sort of classic networking stuff, and you have to set up the etc hosts file correctly. Now this is essential to making it so that the two machines can communicate with each other via NIS, and there's two entries down here at the bottom of etc host that I set up, one for Nugget SUSE and one for Nugget SUSE 2. So you can see here 192.168.1.102 is set to be Nugget SUSE 2. It's also set to be Nugget SUSE 2.site. Now this is a little peculiarity of SUSE Linux. They append this .site onto the end of local domain names, and it's just important to have that in there to get everything to work correctly. And then 192.168.1.103 is set up to be Nugget SUSE, also known as Nugget SUSE.site. So these two entries are in the etc hosts file on this machine, Nugget SUSE 2, and also on Nugget SUSE. That way they can communicate with each other. All right. And etc host.allow has to allow entries from one machine to the other, like we talked about when we were talking about DNS and things like that. Okay, so all the networking stuff is set up. You can also type domain name at the prompt, and you can see your NIS domain name, nugget-NIS. So everything seems to be set up correctly. What I want to do now is I want to show you in the etc directory the password file. So what I've done here is, because what I want to be able to do next is I want to be able to type password, PASSWD, on Nugget SUSE 2 and change my password using NIS over the network. Okay, so there's an etc password file here, but I've taken everything out of it and I just copied it into etc password old for testing purposes. Because when I type password at the prompt, I don't want there to even be a local password file. I don't care if there's one there, I just don't want any entries in it. And so what I've done is I just copied it out to this other password file, password.old, so that I would know if things were being changed locally or if they were being changed over the network. So let me just show you what this looks like. So password, it says changing the password for Perry. Now I've changed my password so many times here, I'm not even sure what it is anymore. So new password, I type that in, re-enter the new password, I type that in, and now it says changing NIS password for Perry on nuggetsuse.site, password changed. So you can see in that case it used nuggetsuse.site. That's why it was important to use that, that name in the etc host file. So now we've changed our password, and that password has been changed on, on the server, and so any machine in the network, whether it's the server or any of the clients, Perry's password is now different. Now, since my password's suppressed, you can't see if I actually changed it, but what I can do to show you that it changed is I can type ypcat password here, and you can see the Perry password in the encrypted form is like DA3Z and so on. And if I scroll back up the screen here, and the last time I typed ypcat password, you can see the Perry password was like OQKV and so on. Okay, so you can see that the password file has actually been changed via that password command. Now, one thing I forgot to tell you about was over on Nugget SUSE machine, you have to make sure that a particular service is running here. So in the etc init.d, it's called yppassworddaemon. All right, and this service needs to be started. I already started it. That's why the last command worked. If I hadn't started the service over on Nugget SUSE 2 when I ran the password command, what it would say is that the yppassworddaemon is not running on the server, and it would stop. It wouldn't let me change the password because it wouldn't be able to change the password. So on some systems, yppassword is the command that you use to change the password over the network. In SUSE Linux and most modern versions of Linux, yppassword has just been equated to the password command, and then you have to have the yppassworddaemon running on the server to accept those changes. So, so that's an important script or an important service to have running if you want to allow clients to be able to change their password over the network. If you're not running SUSE Linux, obviously you're not going to have the YAST tool available to you, but a lot of distributions of Linux have some sort of graphical tool to allow you to configure NIS, and they're all pretty similar to YAST. I just pulled up the Linux how-to on NIS here, and on this page they go through how to configure everything by hand. So if you don't have a graphical tool available to you, you should consult this documentation. Down here it talks about how NIS works, but the specific sections on setting up an NIS client and setting up an NIS server, which is what we did through YAST, are very detailed and explanative. Okay, so what they tell you is where to get the software. They also tell you how to compile the software on your machine. They talk about the various configuration files like ypserv.conf. They point you to some useful man pages, ypserv and ypserv.conf man pages. They also give you a command here to make sure that the port mapper is running, so they're just walking you through the process step by step. Another thing that you have to do if you're configuring things by hand is you have to create the NIS database by hand. So that was done automatically by YAST for us. But in here, this command, the yp-init command -m, this command needs to be run on the master server. That's what the -m stands for. And that master server, that yp-init on the master server will create the database that is then shared amongst all the different machines in the network. They also talk about slave servers in here. That's something that we skipped because we have such a small network. But they go through the commands that you should run on the slave servers, how the slave servers update, and some cron jobs that you can put onto the slave server so that you can keep up to date, so that you're always up to date with the information from the master server. Okay, so like I said, consult the NIS how-to page here if you need to do anything manually or if something's broken. They have a section on troubleshooting as well. Now let's move on and talk about configuring a DHCP server in Linux. We've already been on the client side of this equation. We've configured a DHCP client, and that's really simple in Linux. Configuring a DHCP server is not very difficult either. There's a daemon out there called DHCPD, and that's the daemon name that you're going to use to start and stop the service. And there's a config file in the etc dhcpd.conf file. Okay, so this configuration file allows you to set the important parameters for a DHCP server, and those are a range of IP addresses that you want to give out. So you specify the starting and ending point of the IP addresses that you're going to give as a DHCP server. You're also going to specify a duration. So when some DHCP client gets an IP address off you, they can only keep that IP address for some amount of time, and that's defined in the dhcpd.conf file as a lease time. There's going to be a sort of a default lease time, and there will also be a maximum lease time. So if their client has that IP address for the maximum lease time, then what happens is that will expire, and then the client will have to ask the server for a new IP address after that expires. There's also the possibility of assigning fixed addresses in dhcpd.conf. So fixed addresses would be for like a name server or a printer or something like that. So if you want to assign particular addresses to particular hardware devices like a printer or a name server, you can also do that in dhcpd.conf, and you do that by specifying the MAC address of the device. All right, and you can learn the MAC address of a device by using the ifconfig command on that device. It'll tell you what the MAC address is of the network card or the printer that you're trying to assign a fixed address to. All right, well, here's a sample DHCP config file that I pulled off the internet from yolinux.com, and this just shows some examples of what we were just talking about on the whiteboard. One thing to note before we start looking at the config file is that any changes that you make to this config file then you have to restart the service so that those changes are reflected. They talk about starting and stopping a DHCP server up here. This is the Red Hat way, service DHCPD start. In SUSE Linux, it would be /etc/init.d/dhcpd start or restart. Okay, so that's the commands to start and restart the server, and down here, the very first thing in here, you can see that they specify as a subnet and a net mask, and then they specify the range of IP addresses that they're going to give out to DHCP clients. Okay, and then as we go down farther, you'll see that they specify the lease times. So the lease times are specified in seconds, and that turns out to be like 6 hours and 12 hours. So if you have that lease for a particular amount of time, then the lease file on the server will note that, and then it will require you to ask for a new IP address if you've had it for too long. Down here is where they specify fixed addresses in the dhcpd.conf file. So there's a particular server out there like ns2.yourdomain.com, some name server. All right, and then they specify for that particular hardware address of that name server, give it this fixed IP address. Okay, same goes for a laser printer. Instead of specifying, having the laser printer get the IP address dynamically, instead we give it a fixed address of 192.168.1.120, and it's for that particular hardware MAC address. All right, so the thing is here that if you ever make a change to your printer or something like that, then you're going to have to change this configuration file so that your printer will be found on the network. And these hardware MAC addresses can be determined by looking at the ifconfig program. That ifconfig program will display those MAC addresses for the network device that is that you're talking about. So if you said ifconfig on the Ethernet card of this particular name server, that would be in the MAC address field of ifconfig. Well, now let's move on and talk about PAM. PAM stands for Pluggable Authentication Modules. The idea behind PAM is that PAM separates out privilege granting software from authentication software. So think of this example, like the login process for Linux. Well, the login process for Linux and Unix hasn't changed much in 30 years. What has changed is the authentication mechanism that the login process uses. Back in the late 70s and early 80s, they did a certain kind of encryption that nowadays, anybody could crack with a couple different scripts and a $300 processor. Okay, so that's a problem, right? That authentication systems change over time because of insecurities or computing power that makes old authentication systems obsolete. Okay, now what the problem with that is that the privilege granting software like the login process for Linux, well, the authentication mechanism was built right into that process. So when that algorithm was deemed inappropriate and insecure, then what they had to do was they had to go back and rewrite the whole login process to use a new authentication mechanism. So see, what they're trying to do is separate it out. They're doing good software design here by separating out the authentication scheme from the privilege granting scheme. So, the login process is the same. It's just when you are granted authentication, the login process is going to open a shell and give you access to a home directory and various groups and all that kind of stuff. But the authentication software, it could be typing in a password, it could be giving a fingerprint, or one day a retinal scan, or who knows what it's going to be 20 years in the future, what we're going to do to authenticate ourselves to computers. Okay, well, PAM was developed with that idea in mind, that we don't want to have to keep rewriting all these pieces of software just because the authentication mechanisms changed. And then as a system administrator, PAM lets you decide what authentication mechanisms to use for various applications that are out there. Now, these applications have to be what we call PAM aware. They have to use the various modules that PAM gives us, but they already were using, they already had to be rewritten because their old authentication schemes were bogus. And so then, when they rewrote them with PAM in mind. Okay, so let's give a little overview of how PAM works. So here's a Linux pluggable authentication module, okay? And then there's some application out here, application X. Well, for that application X, there's a PAM config file X that lives in the etc/pam.d directory, okay? This PAM config file specifies certain things. It specifies, what needs to be done for authentication and so on. And then this Linux pluggable authentication module will take this application, it will take the information from the PAM config file, and it will process that and either grant or deny access to the user trying to run this particular application. Okay, so this sits as the intermediary between a user running the application and getting access. It all has to go through this particular pluggable authentication module, which gets input from config files that the system administrator defines. Okay, so let's take a look at the kinds of things that get set in a PAM config file. So each line of the PAM config file contains 5 elements: a service name, a module type, a control flag, a module path, and some arguments there. Okay, so let's talk about what each of these means. A service name is like the application that we're talking about, so like an FTP process or a login process. There's all sorts of services that are controlled by PAM, and you can see what all those different services that PAM controls on your system by looking in the /etc/pam.d directory. There's also an other config file in that directory, and that's kind of like the catch-all. If something's not explicitly specified in some other file, then other will take control at that point. You have to make sure that the other config file here is not the weak point of the system. Otherwise, there's going to be a way into your system by getting control by using some application that's not specified. Then the other config file will take effect, and if the permissions in there are weak, then that's going to be a hole in your system. So always make sure that the permissions in the other config file are strong. Okay, and then there's the module type. So for each of these services, there's going to be different modules that you can define a particular control flag for. So let's talk about what each of these modules are. So the auth module is the authentication module. This establishes that the user is who they say they are, whether you're going to use a password or a fingerprint and so on. Okay? And then for that module, you're specifying a control flag. So you're saying that this is required to gain access. So there's going to be this whole series of lines in a PAM config file for each service. Okay? And in that config file, you have to pass through all of the different lines of the PAM config file. So if for the FTP service, for instance, auth is required, then you're going to do the authentication mechanism that's specified for FTP. If you pass that, then you'll go on to the next line of that config file. Okay? If you don't pass that because it was set to required, then you'll be rejected out of the system immediately. Okay. Another module type is the account module type. Now this is non-authentication based account management. So perhaps you're going to restrict access to the FTP service from certain domains, or you're going to restrict access to the FTP service based on times of day and things like that. That's what's handled by the account module. And then there's a session module that takes care of carrying out certain tasks like logging and things like that that have to be done before or after you gain access to a particular service. And then there's a password module type, and this has to do with updating the authentication token for a particular user. So, so this module takes care of, like updating your password for the FTP service, for instance. Now, these control flags that we talked about, the first one is required. So if some particular module is required, then you have to pass that module's or requirements. Okay, so for auth, if you have to type in a password and it's required, then your password has to meet that. If it doesn't match up, then you're rejected service. If auth was deemed optional for some reason, then PAM will basically ignore it. If it's deemed sufficient, then as soon as you supply, so if auth was sufficient, then as soon as you supply proof that you are who you say you are, then you're going to gain access to that particular service, and you don't have to go through the rest of the PAM config file. The most common kind of PAM config file just has, a set of required tasks. All right. Occasionally, for non-important services, there might be a task in there that is deemed like where one thing is sufficient to gain access. But usually, you have to go through a whole series of steps, and each one of those steps is required, and so that just like sort of increases the levels of security of your system. Okay, module path is pretty self-explanatory. That just gives a path to where the actual module is for that particular service. And then arguments are just like Linux-style arguments. For the ls command, we have various flags that we can pass the ls command. And some of these modules that are specified for certain services, we might want to pass certain arguments to that module to make it behave in a particular way. Now, with all this being said, you can look at various config files out on the internet for setting up certain things. in most modern Linux systems, I mean, ever since like Red Hat 7 and SUSE 6, I mean, this is like years ago, PAM has been configured into these Linux versions, and all the config files are basically set up, and you shouldn't really have to mess with them to have basic security that you would expect in your system. Okay. Now, if you want to do something special, like require some crazy authentication scheme for the login process, then that's up to you as the system administrator, and you should consult a PAM how-to page, or the PAM System Administrator's Guide is a very detailed explanation of all the different services, all the different modules that are available for PAM, and what you can do with those modules. Okay, well, it's time to wrap up our nugget on network management. We started the nugget by talking about NIS, the Name Information System. And NIS gives you a way to keep certain information in a central location on your network, so that you don't have to replicate this information all over the network. So things like password files, host files, things like that can be kept on one server, and then the other machines in the network can probe that server when they need that information. Then we talked about setting up a DHCP server. We looked at the configuration file for DHCP, which sets up the range of addresses and the lease times and things like that. And then we moved on and talked about PAM, or Pluggable Authentication Modules. And this is kind of central to Linux security and authentication for a whole bunch of different services, everything from FTP to the login process to secure shells and so on, are all authenticated with PAM modules. Well, I hope you found this nugget informative, and thanks for watching.